So we finished this section on parabolas. Okay, we finished that section on parabolas. Our next section for chapter 9 is circles. Okay, so we're still writing out these equations just like we were for parabolas, except now we're looking at circles. Okay, so a circle is the set of all points in a plane that are equidistant from a given point in that plane. Okay, so you have a center and you have a point on that circle. That center is the same distance away from all of those points around that circle. That's what that equidistant part means. Okay, any segment with endpoints at the center and a point on the circle is called the radius. Okay, so we're going to assume that this coordinate x comma y are the coordinates of a point on the circle at the right. The center is at HK. So just like we had a vertex point in our parabola called HK, now our center point in our circle is HK. And our radius R is right here. You can find the equation of a circle by using the distance formula. Okay, so our distance formula, again, looks like this. We'll have x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, so this is your distance formula. We're going to use that in our points of our circle here to find the equation of a circle. Okay, so our distance will be our radius. Okay, so we're looking for the distance between those 2 points. So I'm going to change that to R. Shh. Guys, I really need you to pay attention and be quiet. Since I'm using these 2 points, I'll call this x sub 2, so we'll have x minus x sub 1 is h squared, plus, since I started over here, this is my y sub 2 value, so we have y minus, this is my y sub 1 value, k, that is squared. Now if I were to square each side of my equation here, I'd end up with r squared is equal to x minus h squared plus y minus k squared. This is your equation of a circle. Okay, so you'll have your radius squared at the end. So you'll have to find your radius and then square it. Your h and k values are the center point there. So you can plug in those h and k values for your center point and keep x and y the same, and that's the equation of your circle. Okay, so we have that in that table below here. Okay, just like we had for parabolas. We have 2 forms. However, this form is only when your center point is the origin. Shh, you're being very rude. Okay, I'm sorry, but... Alright, can you pay attention now? So this is the form only when your center point is the origin. This form is when your center point is any other place on your graph. Okay, so your center is at HK. You can plug in H here, K here, and then your radius squared. Okay, so if I look at my first example here, a certain Wi-Fi phone has a range of 30 miles in any direction. If the phone is 4 miles south and 3 miles west of headquarters, write an equation to represent the area within which the phone can operate via the Wi-Fi system. Okay, so here, if I draw out my coordinate grid, and I say headquarters is at the origin. Okay, so this point right here, that's headquarters. Now the phone is 4 miles south. Okay, so we'll go down 4 miles. And it's 3 miles west of headquarters, so we'll go to the left. Okay, so this is where the phone is. Now it has a range of 30 miles in any direction. So from that phone, okay, if I go this way, that should be 30 miles. Okay, now since it's in any direction, it would make this circle shape around the phone.
Around the phone?
Yes.
Okay, I just need to pay attention to you guys.
Yes, you do need to pay attention because otherwise you have no idea what I'm talking about.
No, I'm trying. I'm just.
We're talking about the Wi-Fi range, not just a circle around a phone. Okay? It's the range of the Wi-Fi. Your headquarters is here. The phone is 4 miles south and 3 miles west. Okay, that's why this point is here. Now, it has a range of 30 miles in any direction. So any direction around that phone is 30 miles. That's why it's in a circle. It's not going to make a square. It'll make a circle. Okay, so now I want to write out an equation of this circle. So here is my center point. Okay, that was at -3, -4. Okay, so your center is at -3, -4. I need the center point in order to write out an equation of a circle. I also need the radius. Okay, your radius in this case is going to be 30. Okay, it's that same distance from the center to any outside point around it. So our radius is 30. So now I'm going to use the standard form up here. My center is h and k. So h will be -3, k will be -4. So I'll have x minus h. H is -3. That quantity is squared. Plus y minus k is -4. That quantity is squared. That's equal to our radius, 30, squared. Don't forget to square your radius. Okay, now I can just kind of simplify this a little bit. If I have minus a negative, it's just a positive. So we can say this is x plus 3 squared plus y plus 4 squared. And then I can square 30. That's 900. Okay, so all I was doing was finding that equation of that circle. So I knew the range that phone could reach to. Yeah, we're just writing equations of circles. Yep.
Did you?
All right, so on the back, there's just one extra step. So we're going to look at a graph. Okay, so we'll be given a graph of a circle. Okay, and we want to write the equation for that graph. Okay, so that means I need the center and the radius. Well, for the radius, I have this center point and a point along that circle. Okay, so you can't just count and say, well, it's like 1.5. You can't do that. You actually have to use the distance formula to find that radius. Okay, so to find the radius, we're going to use the distance formula. So I can label my points off to the side here if you still need to do that. Okay, so we have x sub 1 and y sub 1, and x sub 2 and y sub 2. Okay, so I can take x sub 2, negative 1, minus x sub 1, it's negative 4, square that, plus y sub 2 is 4, minus y sub 1 is 6, and that quantity is also squared. Okay, again, we're finding that distance between those 2 points so that we can find that radius length. Okay, so here we'll have negative 1 plus 4 is 3. That's squared. Plus 4 minus 6 is negative 2 squared. So we'll have the square root of 9 plus 4. Again, when you square this negative, it should become positive. Okay, that's why 4 is positive. Okay, then I can just add those two together. So we get the square root of 13. Now, I want you to leave it in this form. Okay, so leave it in that radical. Because if you remember in your standard form for an equation of a circle, you need to square your radius. So if I just leave it like this, when I square it, the square root and the square will cancel out and it'll just be 13. Okay, so you want to keep it in that radical form there. So now I have my radius. I know what the center point is because it's on my circle right here. Okay, your center is at negative 1, 4. Again, that center point is H. Okay. So now I can use that formula from the front and plug in what I know. Okay, so we'll have x minus h squared plus y minus k squared is equal to our radius squared. Okay, again I have minus and negative, so I can change this to x plus 1 squared plus y minus 4 squared. And again, this square and that square root will cancel. That's why I left it in radical form up here. So this will just be 13. And that would be the equation of that circle. Okay, so first step, find the radius. make sure you find the center, and then you can plug in what you found for that standard form. Questions on example 2? Okay, then example 3, last one. Again, we need to find the distance of that radius. Okay, so off to the side, I can write out my points. I have 0, 0, and 1, 5. Okay, so I have x sub 1 and y sub 1, x sub 2 and y sub 2. Okay, so I'm just labeling those so that I can put them into the distance formula. Okay, the distance we're finding is our radius, so r. We'll take the square root of x sub 2 is 1, minus x sub 1 is 0, squared, plus y sub 2 is 5, minus y sub 1 is 0, it's also squared. So we have the square root of 1 squared. Okay, 1 squared is just 1, plus 5 squared is 25. Okay, so I have the square root of 26. Again, leave this in radical form. Okay, so our radius is equal to the square root of 26. Our center point is at 0, 0 this time. Okay, that's where our center is. Again, that's your h and k value. So I can use that form from the front and plug in my values. So we'll have x minus h is 0 squared, plus y minus k is again 0, that's squared. That is equal to our radius, square root of 26, squared. Now, if I have a 0 here, I can just rewrite this as x squared. Okay, so you have a center point, the origin. We could write this as x squared plus y squared. Again, my square root and my square here cancel. So this will be equal to 26. Okay, so again, use the distance formula, which is what we did in the first section of chapter 9. Okay, use the distance formula to find your radius. Make sure you locate the center point, and then plug in those values to write out the equation of that circle.